So yeah, let's get started. So this session is going to be Android engineering for scale. I'm Jamie McDonald, and I work as a mobile engineer at SoundCloud. If you're not familiar with SoundCloud, we're a music and audio streaming platform. We're actually based all the way over in Berlin, Germany, but we have an office here in New York and smaller ones in San Francisco and London as well. So what's this going to be about, and what is scale, and what does that even mean in the context of mobile app development? So I'm going to talk about three different concepts. There's the growth of the size and complexity of your code base, growth of the user base, the number of users, and growth in the number of developers that are committing changes to your code base. So right now, Android at SoundCloud is around about 8 engineers shipping something over 100,000 lines of code to something in the range of the tens of millions of users. But these are all things that have scaled up like really significantly over the last few years. So if we look back to 2013, we only had 2 people working on our Android app. They were building essentially one feature at a time and releasing things in an ad hoc way, just whenever that was ready. And today, in 2015, our engineering capacity on Android has increased 4 times. We're able to work concurrently on many different features, and we have increasingly automated development and QA processes that allow us to release on a fixed 2-weekly schedule. So I want to talk about some of the changes that have occurred over this period, in terms of the way that we work, the way that our team is structured, the things that we've learned and come to value, and also touch on some of the stuff that we're still working on and we don't necessarily have the best solution for quite yet. Just to give you a little more context in terms of what sort of stage we are in this growth journey right now. Our Android application gets around 4 million downloads every month. SoundCloud as a platform has over 175 million monthly listeners. And especially in the last couple of years, the mobile apps have really become our most significant platforms. So our Android app leads the way in terms of listening time, which is our key metric. And the monthly listening on Android has doubled in the last year. So it's kind of Android first. And our product is relatively complex as well. So audio streaming isn't necessarily the most straightforward domain in general, but there's a lot of other stuff in there. So we have search and discovery and our stream collections, profiles, audio recording. We have custom ad formats, including audio ads, custom tracking backends, and the most recent feature that we shipped was Chromecast support. So there's a ton of different things in the application. So the first theme that I want to talk around is the growth in terms of the code base and its size and complexity. So the things that we've been doing to keep it maintainable by investing in our architecture, evolving the way that we work, our development practices, and paying off our technical debt. So our Android app didn't always have such a well-defined architecture. Some parts of it started out as a bit of a ball of mud, where there weren't really any separation of concerns between the collaborators. We had problems like database queries being constructed in code that was really more about the UI. We had API calls kind of everywhere. And the other problem was that there was a lack of kind of protocols or contracts for how we would consistently deal with concurrency and errors. So we started to make some changes, and the first thing that we did was to split our code base along the horizontal axis based on technical concerns. So we introduced a layered architecture with a presentation layer, which includes things like fragments and activities and views and presenters. We have our middle layers, our operations layer with all of the kind of SoundCloud specific business logic, and a data layer for storage and network. But we also split on the vertical axis around business concerns. So we completely reorganized our code base into feature verticals. So this leads us to a point where we have this really nice set of boundaries in both the horizontal and the vertical axis. It's much more clear where things fit into our architecture. The layers make it very easy to change things in isolation. There's a clear contract and a set of responsibilities for each of the layers. So just for one example, if you ask to load something from the data layer, as the operations layer, you don't really have to know anything about how that's done. You don't need to know whether it's in the database or shared preferences or any other storage mechanism, and those things can be completely transparent to the caller and easier to change in isolation. And on the vertical axis, we just rearranged our Java package structure into feature packages. So one of our features is the stream of new sounds that people have posted. And we group all of the classes that are associated with all of the technical layers of the application under one feature package. There's a couple of advantages to this. So the first one is that you get to use Java package scope properly, so we can decrease the visibility of some of our collaborators. The much more meaningful change, though, is that our application package structure starts to resemble a set of the features in the application. It's a meaningful package structure that tells you something about what the application does, not just which platform it runs on. And in contrast, we used to have packages which were based much more around technical concerns. So we had a package full of activities and a package full of fragments, and these are not really actually useful groupings. So that was all well and good, and that got us pretty far. But we realized that we actually had this much more fundamental problem. So we improved our architecture, but we had this lava layer problem. So this is when successive, well-intentioned changes to the architecture throughout the lifetime of a project can lead to a fragmented and hard-to-maintain code base. So we have like some parts of our application, even now, that are 3 or 4 years old. And even in the last couple of years, we've been through a lot of different iterations of the kind of the right way of doing things. And as we've introduced new features, we've left different features in different states of the right way of doing things, and never kind of gone back to kind of apply the new patterns consistently throughout the code base. So this kind of prompted us to take a bit of a step back and think, is now a good time for us to define what it means to write Android at SoundCloud? What should our code base look like, and what patterns should we use going forward? So what we did was we started an initiative to create this kind of internal documentation of our architecture and development guidelines. So what we came up with, this was kind of like a collaborative Google Doc where the whole team participated in defining like how we want to build Android apps. And we came up with this thing called Spocker, and I'm not going to try and sell you our architecture. I just want to make the point that this was really an incredibly useful exercise to go and think about like how you want to structure your application and document that consistently. And I think if you repeated the exercise with your own teams, you might come up with something very different that makes more sense for you, but it's a valuable thing to go and do. So the things that I can specifically point out that we got from this process is a much more consistent way of naming components, which helped with communication, because it meant that when someone is talking about a presenter, like everyone knows what they're talking about. Everyone's using the same terminology. And we better aligned our naming with kind of generally accepted definitions of these patterns, so that a new engineer who's onboarding onto the project doesn't look at this thing that's called presenter and go, well, actually, isn't that more of a view controller? So we have this kind of consistent language for talking about components within the team, but also onboarding new people. And the other effect of this was that we started to be way more strict at this point about the use of presenters to abstract components away from the Android framework for reasons of testability. But probably the thing that's most significantly changed the way that we write code is reactive programming. So we use RxJava extremely heavily. We were amongst the first adopters on Android, and this really came out of firstly, a dissatisfaction with the default threading abstractions on the Android platform, but also some desire to be able to use some of the elements of functional programming to express complex logic in this really kind of succinct and stateless way. So before we made this transition, we were using some combination of async task and loaders and more custom threading stuff, but really none of those things are a good time. In terms of the architecture that I described and our layers of our application, the way that we use RxJava tends to be that we observe things that are in our data and our operations layer, and we subscribe to things in our UI. So we also use an RxJava event bus, which means that we have a consistent model of dealing with streams of both events and data. So this really goes back to one of the problems I talked about with our ball of mud, where we didn't have any consistent ways of dealing with error handling or with concurrency. And now we have one kind of framework that does both of those things really well. And I mentioned that we have some kind of legacy components. So one of the biggest tools that we've been using to kind of replace these is the concept of branch by abstraction. So in a more traditional branching model, when you want to replace some component or make significant changes to it, you have your one copy of the code on master, and then you branch away from that. You create your new component, and then a week later, when that's ready, you try and merge that back to master, and you hope that nothing has changed in the meantime, or you deal with some horrible merge conflicts, or you continuously merge master with your branch. But all of that is kind of a lot of work. So what we've been moving towards is use of branch by abstraction, where both of these versions of this component can coexist on the master branch. We get all of our code integrated as soon as possible, and we still use the old component because the new one is not ready yet. But eventually, they're sitting behind this abstraction layer, and when the new component is ready, we switch over to using that, and then we can delete the old one. And then we can remove the abstraction layer, and everyone was working on the same copy of the code. It was all on the master branch. So what this leads us to is trunk-based development, because these kind of long-running branches are not agile, and they're in conflict with the principle of continuous integration. So we want to get all of our changes onto our master branch as soon as possible. And if you're working on something that's not quite ready to ship yet, it's sitting there, but it's turned off. So this has worked really well for us, and it's really allowed us to scale the number of kind of features that we work on in parallel without getting caught up with any painful merges or having to maintain different copies of the code. So what we use for this is a pretty lo-fi feature toggling system based on Gradle build properties. So this is mostly for development stuff. So I'm working on this feature that's not quite ready yet, and I want to have it turned off or use some placeholder in the meantime. So you can make this decision about whether a flag is enabled or not and decide what to do based inside a factory or a provider, or just have an if statement somewhere in your business logic. And we have different configurations of features for different build types, so for beta and production, for example, and they're even toggleable at runtime for our debug builds. So to give one really concrete example of where this was really useful, last year we pretty much rewrote our entire playback stack from the audio streaming through the play queue management and the whole UI of the player. And this was a pretty big project. It took us about 3 months. But we were able to do this alongside the old player. So for a while, you could switch between the new player and the old player, and then eventually the new player was ready to ship. So we just flipped the switch. Once it was in production and everything looked good, we could just delete all of the old code. And lastly, for this section, we kind of started to restructure our repositories. So before, we were using just one big single repo that contained a bunch of different stuff. And we've been splitting this out, so we still have a main repo, and we still have some ambitions to modularize this further, but we just don't have any satisfying solution for that. But what we did do is pull out a bunch of libraries, so a set of utilities, and some other kind of tooling, so that we could have these much more focused libraries with better defined APIs. And then we also have things like our native player, which are a totally separate project. So the next set of things that I want to talk about are around the growth of our user base. And actually, because it's a mobile app, this has really had the least impact on how we work. So to some extent, there is an element of increased risk when you're rolling out to a small percentage of a really big number. It still is pretty dangerous. And we try to mitigate that in a few ways by putting everything through a beta channel before it goes to production, etc. Really, the big impact here is on end-to-end development. So most of the mobile engineers at SoundCloud are working on one of the client applications, but also contribute a bit to our mobile API, which is shared between the Android and iOS clients. And the growth of the user base does have some impact on how we do API design. So we're much more careful about batching up our calls to internal services and optimizing the requests and responses, which is better for the client because it needs to make fewer calls, but also better for our server load. However, we didn't always have the flexibility to be able to do this. The very first versions of our mobile apps were based against our public SoundCloud API, which is good for dog fooding, I guess, but it meant that we had our Android and our iOS app using the same API as hundreds or thousands of third-party clients. So we were totally unable to optimize for our own use cases, for our own clients. And it was also incredibly slow to change because we didn't want to break anything for our partners. And what we've migrated to is this mobile API layer. So this evolves alongside our client apps, and it sits between all of our internal microservices and our clients. So this is written in Scala. It's based on an internal framework that we call BFF, which is back-end for front-end, and that kind of describes how this is just this stateless layer between our services and our clients. So this gives us much more control over what we return from our API, and it also means that we can do more ourselves. So we're not sitting around waiting for other teams to build stuff for us. We have the control to do that ourselves. And so the public API responses, these are totally different calls, by the way, but the public SoundCloud API responses are these really heavyweight JSONs. They've got everything you could possibly ever need for anything you'd want to build. But the responses that we return from our mobile API, they're still JSON, but they're much more kind of light and specific, and usually they're kind of tied specifically to one screen of the app, so they're much more tailored for our clients. And the other advantage is that we have more flexibility. Like if we wanted to switch from JSON to like protobufs or something, we would be able to do that. And one other challenge with the growth of the user base is kind of maintaining user empathy. So kind of remembering that what you build actually has some kind of impact on individuals. There's people sitting there using the stuff that you're building. So this is something I think is kind of an interesting problem. So I spent a couple of days of my 20% time building this information radiator, which shows a bunch of reviews, like the latest reviews from the Google Play Store. So this has been pretty cool. We have it displayed on a bunch of screens all over our offices. And this gives kind of like an awareness of the issues that keep coming up. So you kind of learn to spot patterns. Like we keep getting like one-star reviews that mention this bug. Maybe we should do something about it. And it's also kind of like a nice like glanceable meter of user sentiment at any given time. And so the last theme that I want to talk about is the growth of our team. So I mentioned that we'd grown from just a couple of engineers to around 8 people working full-time on Android. But we've also changed significantly the way that we structure our teams and the way that we work more generally. We've been in the process of moving from platform teams to feature teams over the last few months. The motivation behind that is to drive more of a focus on very specific use cases in our application, but also it's going to allow us to scale our Android capacity beyond the kind of limits of team size. One other thing that's changed pretty recently is that we have like a lot of other engineers from different parts of the company who've started to contribute to our mobile apps. So that's also been really exciting. So this is what it used to be like. We were these platform teams, the Android team and the iOS team. And we were kind of under this mobile umbrella, but like really like separate from like this thing like way over here, which is like everything else in engineering, and that's kind of a lot of stuff. So this actually worked like really well up to a point. We were all kind of sitting together at one desk in one office in Berlin, and there's really like low communication overhead. We got a lot of stuff done pretty fast. But there's kind of disadvantages of this as well. Like we're a bit detached from everything else that's going on, and the way that we got anything done was that lots of other teams from the other part of the organization would come to us and say, can you build this thing for us? Can you build this new search feature on Android? And then we had like a single PM for the mobile apps who has this impossible job of trying to prioritize this thing that search has been asking us to build for a year against like some playback bug fixes or something. So what we're moving towards right now is this feature team model, where we have teams based around all of the different verticals of our product. So one of them might be search, one of them is like playback. And then we have a core team that's building more kind of like infrastructure and tooling and supporting our feature developers. So we have a core team for Android and iOS, and then all of our other mobile specialist engineers are distributed amongst these verticals. So let me explain you one specific example of this. So the screen all the way to the right is our player. And we now have like one team, the playback team, which is building the player across all of the platforms. So they build this part of the Android app, but also they build the player on iOS, and they build all of the streaming backend. So it means that all of the different experiences in our application are owned by different teams, but they're still all built with a set of consistent patterns and a consistent way of doing things, which kind of also came out of this like Spocker architecture and the whole self-reflection around how we want to build Android apps. So this is like SoundCloud, or at least most of it, and we probably have something like 100 people in engineering. So we've also had 2 engineers who didn't have any mobile background who started working full-time on Android, and around 20 people in total who have contributed something to the Android code base, whether they're working full-time or they just like committed one thing and never came back. So we've been doing some work to try and support this, to make it easier for other engineers to get involved. So we run things like install fests, where we just get everyone together, get them set up with Android Studio, with all of the tooling that they need to build the app and run the tests, and maybe build a very simple feature. So we have some kind of onboarding documentation to help people get started as well, though that's definitely, I think, an area that we know we could improve. And the typical model for someone who's not a mobile engineer getting involved in the Android or the iOS app right now is just that they will like sit and pair with someone who is a mobile engineer, and this also seems to be working pretty well. So yeah, now that we're split amongst all of these different teams which have their own kind of business concerns, as well as a set of kind of cross-functional specialties, how do we continue to have a set of collective values around like what we build and how we build it. So part of this is that we have the Android collective. So this is just everyone who works on Android, and we still have like a mailing list, and we still have a Slack channel, and we meet I think every week to discuss like cross-cutting issues, more kind of cross-cutting changes to the application, and to continue to evolve our kind of patterns and practices and ways of working. So I want to talk about a few of the things that we kind of came to value over this sort of journey. The first one is code review. So all of the feature code that goes into our app gets reviewed, even when we pair, and we pair quite often. So this is not only to maintain code quality, but it also helps us to kind of collectively ensure that everyone's adhering to these accepted patterns, and we have consistency across all of the different features. We value testing extremely highly. So this is at both the unit and the acceptance level. We have shared standards around what should be tested, and aim to test all of our business logic. And we've built some stuff that makes it a little bit easier to test on Android. I mean, the first thing we do is that we create very thin activity and fragment classes. So they have almost nothing in them, and they delegate all of the logic to other collaborators. And one of the tools that allows us to do this is this thing called lifecycle. So this forwards all of the Android lifecycle callbacks to other components. And this is really useful because it means that in this example, this is the main activity, and it has a player controller, but the player controller can still receive an on-resume event and an on-pause event. So we can test that, we can unit test it in isolation. We never have to create an instance of the main activity. So that's pretty helpful. There's this kind of focus on small testable components that are abstracted a little bit away from the Android framework. And the other thing that we do is whenever we have some dependency on a third-party library that we can't necessarily test, we just create a wrapper around this so that we can at least verify our interactions with that library. And this has the bonus that if we want to replace some dependency, like if we want to throw away our image loader and move to something that has an equivalent API, we can do that in just one place. So in terms of tooling, we used to use Roboelectric 1 for a really long time, for far too long, actually. But we're now in the process of migrating from Roboelectric 1 to Roboelectric 3. We did look at all of the other options, including the new unit testing support. But we ended up with Roboelectric 3. One of my colleagues, Matthias Kepler, wrote kind of a Google Plus blog post on all of the options that we assessed and why we are putting our money on Roboelectric 3. So if you're more interested in why we made that decision, then check that out. And for acceptance testing, we have a custom instrumentation framework. It uses Robotium as a driver, but it's more kind of based around page objects. So we have these abstractions where you can write like search screen dot click on search field dot type dot search, and then make some assertion on what it did. So we don't have a QA team at all. We don't do really any manual testing except from when we're about to make a release. So we're really heavily invested in automated acceptance testing. We do this for all of our features. Because we don't have any QAs, we're pretty motivated to actually go and write automated tests, because that means we're spending less of our engineering time running manual regressions when we are trying to release our app. So currently this all runs on like a bunch of Nexus 5s in some cupboard in a corner of our office in Berlin, which is also something that we're kind of working on. Like we could probably do this better. So we're working on some kind of new tooling so that we have more flexibility around which sets of devices and platform versions we run our tests against, and being able to use some like virtual machines and stuff as well. And so at the very beginning of the talk, I mentioned that we have this release train, and we're releasing every 2 weeks. So this is kind of what it looks like. We put the new version into the beta channel for 1 week, and then we promote that to production, and it's there for 2 weeks before the next version arrives. So this process is something that is kind of driven by this release captain role that we have, and that is something that kind of alternates amongst all of the members of our Android collective. And they are kind of like driving the process forward, like making sure we're doing all the right things to get a release out. But it's really the individual feature teams who are responsible for getting their changes on the train on time. And this is all like completely supported by our use of feature flags, which I talked about earlier. So we can just say, like, if this feature is not ready, it's just, it doesn't ship, it's going to stay turned off. And if you have a feature that you think is ready, but then in beta it turns out it's totally broken, then we can just turn it off, and then it will go into the next release in 2 weeks once it's fixed. So releasing is definitely something that we're still working on. We still find it to be a pretty painful process. But these kind of ad hoc big bang releases just didn't scale with our team size. There were too many changes to do it without this kind of structure. And I think one thing that we kind of aspire to do better here is better support for remote feature toggling and staged rollouts in production, so that we can launch without really launching any specific features and then turn them on and see how they perform. So this is something that we don't really have yet, but it's something we're kind of aspiring to do better in future. So that would really help us to be able to release more confidently. Yeah, and I mentioned that we do some kind of manual regression testing. That all happens before we release the beta. So for all of the things that we don't cover in our acceptance test suite, we have a set of scenarios that we have to run through before we can release. And then we have some more tooling that our test engineering team has helped us to build. So we have this release and promotion pipeline where every build goes through a set of steps. Like there's the build and static analysis, and then unit tests, and then acceptance tests. And if you get all the way to the end of the pipeline with green builds, then there's a button in Jenkins you can like click to deploy a release version of the application. Yeah, so to summarize quickly, the things that have kind of changed as we've grown and evolved our processes. So we introduced this featurized layered architecture, which gives us a much better kind of separation of concerns, much more consistency and structure in general in our code base and how it's organized. We started doing trunk-based development so that we're able to work on a lot of different things at the same time without stepping on each other's toes and just maintaining one copy of the code. We also moved to feature teams, which focus on one specific use case within our application, but they're full of like people who specialize in different areas, like mobile development or backend, and they're all working on some feature like search together, and that includes like end-to-end development with our mobile API. But through all of these changes, we've been trying to maintain a set of shared values, which are things like testing and user empathy, and a set of shared practices around the tooling and libraries that we use. So, for example, reactive programming. But of course, there's still some stuff that we're working on that isn't quite there yet. So I mentioned that releasing is still quite painful. It's definitely something that's still got a lot of our attention in terms of our aspirations to improve it. The feature team transition that I described is still kind of a work in progress. Like, I can't say for sure that what I presented is going to be the way it ultimately ends up, but I think we're on a pretty good path there. The problems that we have so far is that we have verticals of our application Like for example, there's a sign-in team, but there's no Android developer for that team. The other things that are potentially difficult in this model are like the coordination of cross-cutting work and the ownership of platform-specific stuff. Like when we migrate to runtime permissions, it's not totally clear who's going to own that piece of work. And then finally, we would really like to get better at open sourcing some of the libraries that we build. So I mentioned Propeller, this, no, I didn't, that's what I'm about to mention. But I did mention Lightcycle, which is this kind of annotation processor that forwards activity lifecycle callbacks to other collaborators to make them easier to test. We also have a pretty mature SQLite library called Propeller, which we would like to open source, and we've been kind of redoubling our efforts behind this initiative pretty recently, so hopefully we'll have some stuff for you soon. But yeah, that's basically the end of the talk, and of course we're hiring Android engineers here in New York and in Berlin. So if that sounds interesting, then come and talk to me at some point. I'll be hanging around. But otherwise, if you have questions and stuff, I guess it's easier if you just come up and talk to me afterwards. So thanks a lot.